Welcome to Frost & Sullivan's Growth, Innovation, and Leadership Briefing. Today's event is titled, Startups Driving Innovation in Upstream Oil and Gas. My name is Anna. Over to Rashaleen.
Thank you. My name is Rashaleen Nakra, and I'm the Industry Analyst at Frost & Sullivan. I would like to thank everyone for attending and also our panelists for agreeing to participate in the webinar today. As part of Frost & Sullivan's Oil and Gas Innovation Council, just to give you a brief overview of the council, the Oil and Gas Innovation Council spotlights emerging technologies, innovations, and new trends in the industry. So overall, the council's mission is to leverage innovation to help increase efficiencies and reduce the cost and complexity of the upstream oil and gas. And so before launching the Innovation Council, we interviewed dozens of innovation leaders in the oil and gas industry, asking what are the critical issues that the industry was facing. And one of the top issues was monitoring the leading startup companies and how they impact the bottom line. And hence, one of the deliverables of the council is the monthly report, where we profile the promising startups. And you'll see in this slide, on the left-hand side, you can view the top critical issues of the industry. And on the right-hand side, there are in-depth themes of our research team that we are covering this year. So now, without further ado, I will go ahead and let the panelists introduce themselves and their company solutions. Our first panelist for today is Talgat Shokanov with Quantum Pro.
Yes, good morning. Thank you very much, Rosaline. My name is Talgat Shokanov. I am a president and CEO of Quantum Pro Inc. I spent 15 years in the industry, mainly on the fracturing and injection businesses worldwide. Had various R&D positions, a management role, and operational role in the Schlumberger. I'm recognized expert in shale and complex fracturing worldwide. And I was awarded Distinguished Engineering and Service Award from SPE. Today I would like to introduce the Quantum Pro. Quantum Pro is a technology company with a mission to develop and deploy unique and smart tracer technology for oil and gas operators. We headquartered in Houston with operation in mainly North America land at the moment. We develop and deploying unique technology around intelligent tracers that is based on our proprietary method to embed unique fingerprints in each of the bags of the particles in our facility in Houston. One of the key value propositions for the customers that we see in that technology, the first and foremost, is a very cost-effective material to produce. The particles itself are light and inert. We can use it for multiple type of the application, all the way from the multi-stage hydraulic fracturing to water injection to waste disposal. The particles itself, in terms of the characteristics, are safe, they're non-hazardous and non-radioactive, very easy to deploy, unintrusive to the completion design, agnostic for different type of the fluid and frac fans. They use also at very high temperature in terms of the downfall conditions. We do all the testing on site, so we took full control and ownership on the quality control and quality assurance on location. We're offering here a quick turnaround time and very high resolution, which goes down to the subatomic detection limit. On top of that, what we see here, we integrate that with our cutting-edge subject matter expertise around the frac and the completion optimization. We cut through the different silos in terms of the data set. We drive the next level of the completion and the frac optimization through integrating the pre- and post-frac data during the computing capacity from Microsoft, and coupling that with cloud power computing capabilities, along with the leading domain expertise to enable our customers to build a unique deep learning algorithms that integrate the smart tracer data during the flowback, combined with existing data sets, including the data on the log analysis, petrophysics, geomechanics, and post-frac flow production profile. With that in mind, we can help our customers significantly increase the completion efficiency. We're talking about incremental of the production stage level. We also can optimize the frac efficiency and increase in return on investment in each of the frac stage. We also optimize the sand and water usage for the completion design, In fact, we do much more with the less resources that is needed to gain the better production. We also be critical partner on the frac hit prevention. There is a lot of issues around parent and child interaction, and by measuring the communication between the fracs through the intelligent tracing in combination with our unique expertise, we can minimize that frac hit, at the same time help our customers to optimize the well spacing and positioning of the fractures in each of the stage. And therefore, all that combined, we can increase the completion efficiency and drive for the next level of completion design that help our customers to achieve their goals. Thank you for your attention, and that's it with my side of the presentation.
Thank you so much, Talga. That was great. Thank you. Next up, we have Yvonne with Ingu Solutions.
Yes, good morning, everybody. My name is Yvonne. I'm co-founder of Ingu Solutions. And with my co-founder, I started Ingu back in 2014. And we are based in Calgary, Canada. Today, I would like to introduce you to what we call our Pipers technology to inspect pipelines for oil, gas, and water. As you might all be aware, pipeline infrastructure is aging. There's so many pipelines that are older than 50 years even. And there's also about 40% of all the pipelines in the world that cannot be inspected using conventional tools. That means that that is about 1.5 million kilometers all over the world. And when you look at the tools that are used today, you can see an example here. And as you can see, it's a large industrial tool. There are many people needed. There's machinery needed. You need to stop operations of the pipeline. So it's quite labor intensive as well as highly costly. So our solution is what we call our pipers, and you can see the big guy in the middle holding our small golf ball sized ball, and he's just going to launch. He's about to launch it in the pipeline, and he, as you can tell, he's kind of looking at it. Okay, I'm going to drop a ball in my pipeline. But this was a project in North Dakota last winter. And as you can see, it's really easy, just opening up the pipeline and then dropping it in, and then it literally goes with the flow. So the big advantage of our tool is that we can go into all types of pipelines, so either steel or non-steel. We have a particular focus on the small diameter pipelines. So as of 2-inch, but also, as I already mentioned, those pipelines that can just not be inspected with traditional tools. And that can be because there's too low flow, there are too steep bends in there are diameter changes. And our Pipers technology does not have any restrictions at all to go through the pipeline. On the left-hand side, you see 3 of the small pipers just received in a freshwater line. And on the right-hand side, you can see that our piper is mounted on the back of a cleaning pig. And that's actually the way that we use it in natural gas, because we need something to propel it. When we are in a liquid, we are literally free floating, so we are going along with the flow of the liquid. And that has quite some advantages. That way we can perfectly detect leaks because there's hardly any background noise. We locate deposits. We determine what the pipeline looks like, for instance, to be able to tell an operator that he can indeed use an MFL tool for an inspection. And we look at the magnetic features. The whole way that we offer this is as a service. We don't charge for the hardware, but we only charge for the data that we provide per kilometer. So depending on the level of information, we have different levels of pricing. And as I already mentioned, we have no downtime. It's really easy to use, and we can cover distances as long as 24 hours in inspection. Well, a little bit more about the stage of the company. So 2018 was our first commercial year. And since that time, we screened, in the meantime, 52 pipelines. Every week we add to that, fortunately. This gives an overview of the type of pipelines that we screened. You can see that we went up to 1200 psi, which was a gas line. And below there are a couple of the clients that we can mention that we work with. We work with Chevron, with Equinor, but also Husky Energy, Vermilion, Obsidian are a couple of different operators. We mainly operate at the moment still in North America, but the whole business model is that we provide an operator with a box of pipers. So we're not needed in the field, and then the operator can just deploy the pipers at the time that's convenient for them in the pipelines of interest, and we just do the data analysis. That is a bit more about our pipers technology, and if there are any questions, I'd be happy to answer those.
Thanks, Yvonne. That really looks great. Piper technology is actually something pretty unique. Let's move on to our next panelist for today, Ivitar Miran with Fieldbit.
Yeah, good morning or good afternoon, everyone. My name is Ivitar Miran, and I'm the CEO of the company Fieldbit. Well, in general, Fieldbit is my third startup from inception and success and exit. And also the previous startups were involved in taking new technologies to a very conservative market. Fieldbit started when we identified the need for field service technicians for augmented reality-based solutions, smart glasses and other mobile devices. And soon enough, when we introduced the first product to the market in 2015, we been identified by the energy market as a very valid solution. So what we provide is the 5 different of knowledge sources for field service technician or operator that is on the machine, and that they are able to benefit from this knowledge. And the first one is the connections to field service experts or a colleague that knows how to solve the problem. And using augmented reality, they can communicate and exchange valuable information. The second is through step-by-step instructions, and the third is through a captured knowledge. The fourth is the connection to the CRM or ERP system of the enterprise. And the fifth is the industrial IoT, real-time values. And how does it work? In general, the technicians or the operators can be on site, and having all these sources of knowledge, they are able to solve problems much faster and in the first time. And the result is in the oil and gas industry, in the upstream, is that instead of having a technician going from one well pad to the other, identify a problem, and then sending a technician to the second day, the expert goes again to the same well pad and solves the problem, then what our solution involves is the ability to solve the problem by the technician, either through his knowledge that on his device, or through a face-to-face video communication with an expert that is in a remote location. And actually this solution allows the organization to completely change their business model by having either technicians that are close to the well pad and not having the need to send somebody from far away, or to use subcontractors, or sometimes use the people on site that use the hands and the eyes of the expert on the service center. I think that's more or less. Thank you very much.
All right, thank you. Our last panelist, is for today is Mark McClure with RaceRat Corporation.
Hi, thank you. I'm the founder and CEO of RaceRat Corporation, was formerly an assistant professor at the University of Texas at Austin in the Department of Petroleum and Geosystems Engineering. Let's see, next slide. The problem that we're trying to solve is that engineers optimize hydraulic fracture design to maximize oil and gas recovery and minimize costs. So they have to make decisions like how close together should we put the clusters, how long should stages be, how much fluid and proppant should we inject, how close together should the wells be placed, and many other design decisions like that. Those decisions are the first order drivers on the economic performance of the company, and they're very challenging because it's hard to know what would have happened if you had done something else, and it's also expensive to try new things out in the field. If you haven't tried something before, it takes many millions of dollars to try it out, and then years, or at least a year or two, to determine whether it worked. So numerical simulation is used to shorten the learning curve, and we simulate the physics of what's happening, and that allows us to predict the outcome of different choices about how to design the frac job. And, next slide. What we built and what's unique about our tool is that we've integrated reservoir simulation and hydraulic fracture simulation. So conventionally, these are two different types of software. There's reservoir simulators like Eclipse and CMG. They predict production and they simulate the multi-phase flow period of many years of production. And then hydraulic fracture simulators simulate crack growth. Typically, those are completely different software. And so if you want to do an integrated workflow where you're optimizing production based on fracture design, it's very awkward to have to pass back and forth between these types of software. So we wrote a single simulator. It includes all the physics all the time and can perform the entire life cycle of the well in a single simulation. That can include things like parent-child interactions, refracs, as well as just optimization of individual well hydraulic fracture. So we commercially launched the beginning of 2018, so it's been about 18 months. And we started off as a very small company, just 2 people. Now we have fully launched the beginning of 2018, so it's been about 18 months. And we started off as a very small company, just 2 people. Now we have 7. We've been growing rapidly. We've gotten up to 17 clients that we're working with 15 operators. That's 7 major shale plays and 1 conventional play in the U.S. So all the heavy hitters that you're aware of. We do both software sales and consulting. So we'll do direct software license sales so that clients can use the software themselves internally. And then also we'll perform a soup to nuts project for them. We perform a study. So a typical study, something like this, you set up an initial model based on geologic information. You history match to production and fracturing data, and then you run different scenarios to predict the outcome of different changes in the design. That helps clients decide, what's the next innovation, what's the next thing we're going to try, and really this can make huge swings on their productivity. And of course, frac design has been changing continuously. And that is it for me.
Thank you so much, Mark. Great. So these are our 4 companies here today with broad range of experience. We have Quantum Pro, Ingu Solutions, FieldBid, and RaceRat Corporation. Thank you all for the introductions. Let's go ahead and get into the Q&A session. The first question here, I'll start off with Talget, Quantum Pro. How do you think the Smart Tracer is a better solution in measuring the intra-well communication?
Yes, thank you very much for this question. Let me provide my clarification. So if you look at this complex and challenging issue around the cross-well communication, one of the key area that is required measurement is actually physical measurement of the communication between the 2 fracs on offset wells. On the other hand, if you look at the complexity of the shales and heterogeneity of the shales combined with natural fractures network, it's not always easy to quantify and qualify that production. On top of that, you have the prop frac, which generate a lot of production out of each of the stage, and you have a natural fracture network that close after your pumping phase is completed. So what we do here with the smart tracers, because they enable you to identify prop frac network, and they can be monitored from 2 wells at the same time, you can get a better resolution and quality in terms of the communication between the fractures on a daily basis. So you're talking about long-term monitoring of the live communication between the wells. And you could see very clearly and precisely the signals if you have a cross-frac or cross-well communication. And we're talking about here long-term communication. I think in that regard, we're really leading the technology. And we're providing high resolution and quality in terms of the prop frac to prop frac communication in unconventional multi-well development.
Thank you, Talgat. Our next question here, Ignu's a solution different from the conventional inspection tools.
Yeah, thank you for the question. We're different in a couple of the fields. So when you look at business model, we're quite different because it's a self-service model for which we are not needed in the field. So when you look at cost, for instance, that's a factor 10 compared to conventional tools. Also, in the applications, we're quite different. There are many tools that can do one inspection, one type of inspection, and then if you want to do another type of inspection, you need a different tool. All of our sensors are in the small balls, in our pipers, so we always record all the data of the pipeline, and then depending on the question of the operator, we provide the results for that. And to give you a couple of examples of questions that we get, that varies from really specific ones, such as we lost an MFL tool in our line and we don't know where, can you please locate it for us, to operators that ask us to screen a whole field of gathering lines to be able to set a baseline for future monitoring as well, and then do inspections every 6 months, and then determine which lines are a risk and which lines can be are good. So that also saves costs for the operator on the longer term because we can help them decide when another type of inspection is needed or a repair. Also, when you look at the magnetics, so the big question we always get is, can you do wall thickness? In that respect, we are completely different because we are not have not the high accuracy of the one-time, once every 5 years inspection, but because we can screen a line as often as is needed, we overlay the data, and each time that we see a pipeline, our data becomes more and more accurate on the magnetics. And at the moment, we need about a 25% wall loss that we pick up on. But we had an operator do digs, for instance, and we found bad welds, but also good pipe was indeed good pipe. So our data correlated extremely good with the findings.
That's interesting to know. Thank you, Ivan. Our next question is for FieldBit, Avatar. So what are the key challenges you help your customers overcome?
The main challenge that our customers have is the adoption, because FieldBit is a very innovative solution. Yet it is a off-the-shelf solution. The main challenges are in change management, how to get technicians and other users familiar and change the way that they have been working in the past into the modern and more effective and productive way. most of our customers from C-level and D-level, they are excited from the solution. They see the potential, the benefits, and the value. But when it comes to the technician, there is a need for extra effort. And the way that it is done, that we help them, is by appointing or helping the champion within the organization with a set of tools, including reports, daily reports and weekly reports on the usage, and actually calling the users and getting them to tell us their success. I mean, how much they saved, how much time they saved, how downtime, the machine uptime were improved. And this type of activity and small successes drive other people to use the solution.
Mm-hmm. Thank you so much. I'll go ahead and ask the same question to Mark as well. Mark from RaceRat Corporation, what are the key challenges you think you help your customers overcome?
Yeah, so the problem is that they have maybe 10 to 15 different decisions they have to make at a high level about how to design frac jobs and how to place wells and so on. And of course, with 10 to 15 different design variables, it's impossible to go out in the field and test every single combination of all of them. And so they have to be really smart about deciding, how are we going to innovate? How are we going to decide what to do next? They know that if they keep the same design constant, that over time their neighbors are going to pass them up. So they're trying to always figure out how can we do better. But of course, it's expensive every time that they drill a new well. It takes a lot of money, and it takes a while to drill that well and get production data back. So what we help them do is basically screen ideas and also inspire new ideas. So we run a physical model of what's happening. We can create a movie. We can explain why things happen. We develop better insight into that. And then that helps inspire, hey, maybe we should try tweaking the design in this way or that way. And that helps them iterate towards a better design faster, which has a direct implication, of course, on economic performance.
Mm-hmm. Thank you, Mark. Going back to Talget with the Quantum Pro, how is the smart tracer different from the chemical tracer and other flow profiling technologies?
Okay, so based on the shale well economics, most of the wells that is designed for most of the technologies that is designed for the flow profiling is quite expensive and requires a lot of modification completion design, which in many cases is not on the agenda anymore. I think primarily if you benchmark again the chemical tracers, most of them are dissolvable products that requires at least 2 tracers per stage. They're also limited to molecular detection limit. In contrast, I think Quantum Pro Smart Tracer technology allows a better use of the tracers, so we can use one tracer instead of multiple tracers per stage. We also can be much more cost effective in terms of the deployment and the cost of material. And the last but not least, I think in terms of the resolution, if you look at the fracture characterization and interval communication, I think the smart tracers can have much more benefits in terms of the flow mapping and the fracture characterization that we see based on our deployments today.
Okay, that's interesting. Thank you, Talget. Avatar, I have a question for you here. So how does your solution work without internet?
Okay, as I mentioned, there are 5 sources of knowledge that technicians or operators have. The first is communication with field service, with the expert, and this can be done either through video, real-time video, or through images that the technician can send to the expert. And this obviously requires some sort of internet. Our solution allows a low band also, but internet is needed. For some of our customers, they have managed to have internet also in rural areas by some devices and boosters that they put in their trucks. For the other sources of information, the step-by-step instruction, SOP, and the knowledge, the captured knowledge, this can be reside on the device of the technicians, including the augmented reality. So there is no need for an internet. And there are other more specific pieces of information that also can reside on the device that doesn't need an internet.
Understood. Next one I have for RaceRat Corporation. Mark, what is your technological edge, and what prevents others from replicating the same?
Sure. So the edge is that it's a truly integrated solution with the fracture and the reservoir. So in fact, I see a question here. Someone else asked, does the fracture or the models integrated together? It's not multiple models. It is one model. There's only one interface because it's only one simulation. It's only one simulator. So it really is not like we've just kind of glued together a frac model and a reservoir model. It's one model with all the physics all the time, solving the whole problem together. And that's unique, actually. That has not been done, at least commercially. There are perhaps a few research tools that have done something like that, but they're not commercial products, and they're not nearly as featured as what RaceRat does. So that is a big edge, and I think that's actually going to be very long-term defensible because it is a very different numerical approach. So under the hood, it's not public. We have a patent pending, at least on some of the parts of the algorithm and how things work. But we figured out a lot of new stuff to make the simulator run in a way that's sufficiently efficient and then also flexible enough to solve the equations, and it's consistent. So, for example, a challenge with numerical simulators is they have to converge. They have to be able to solve a large coupled system of nonlinear equations at every time step over and over, and it has to be done very consistently and reliably. And there's a ton of challenge in making this problem that we're solving converge consistently. And so we've figured out a lot of stuff under the hood, and I think that it's clearly advantageous to do it the way we're doing it. And in 10 years, there will surely be other people doing this. But I think it's really hard, and I think that it's going to be a major investment of time and research for any company that tries to do it. So it's not permanently, uncopyable, but I think it'll be a while, and it's much harder than it looks.
Great. Thank you for that answer. So I'll go ahead and take up questions from the audience now. There's one question for Ingu Solutions. Ivan, are the sensors in the Piper giving output in real time?
No. The pipe, we store the data on the Piper, so we need to retrieve them in order to read out the data and do the analysis. And it's just tough to, most of the time we are underground in a metal steel line, so it's pretty tough to transmit data then.
Okay. The next question I have here is the sensor acoustic or magnetic?
It's actually both. So the sensors that are on our Pipers, we have a pressure sensor, so that's one. Then we have an acoustic sensor in there indeed that we use for leak detection, so we literally listen to leaks. We have a magnetometer in there that we indeed use to look at the magnetics of the pipeline, and then we measure acceleration and rotation, and we use that, for instance, for bend analysis.
Great. Okay. I'll go ahead on the next question. This is for Mark, RaceRat Corporation. Is there any involvement of artificial intelligence or machine learning in your firm?
Yeah, it's an interesting question. The answer is not much. The idea of artificial intelligence, machine learning, is derived from big data. You have a lot of data, and you want to search through that data and identify patterns. It's really a statistical approach. It looks back and it pulls out what you've learned from what you've done in the past. That's not actually the primary purpose of what we're doing. We're trying to say, what if you did something you've never done before? It's hydraulic fracturing in shale is not a big data problem. Even if you're a huge operator with years of experience and you have hundreds of wells, it's not like you went out and tried every possible combination of design parameters. You have very tiny slivers of a very large dimensional problem that have been sampled from your previous history. And so it's not a big data problem. And with machine learning, you can't extrapolate out and predict what would happen if you did something new. So, for example, we'll work with an operator and we'll say, well, we think that if you change variable A, that's going to improve production. And they might say, well, we tried that and it didn't work. And then we'd say, but you have to change variable B and C along with variable A, because if you don't change those other variables together, then that change won't work. So I'm trying to be vague there. But the point is that, there's all these interactions and physical things that are happening, and you just haven't tried all of them yet. And so you can't do machine learning on the past if you don't have the experience to learn from.
Mm-hmm.
And I'll also say I think the two technologies are complementary. I think companies should look back at what they've done and see what worked, and that's where machine learning will come in. But we're helping to look forward, and I really think that the two technologies work in concert. It's actually, I like to say it's part of the scientific method. The first half of the scientific method is to develop theory and hypothesis, and then you develop data to test hypothesis, and then you create new hypothesis. And so machine learning looks back at observation and creates conclusions or inference, and then physics helps to predict future things and generate new hypotheses. So I really think they work together as part of kind of a scientific method as you iterate towards improvement.
All right. Great. The next one I have here is, how is the piper pushed ahead?
In a liquid, we are neutrally buoyant. So we're literally in the liquid, and then we go with the flow of the liquid. If it's natural gas, we use the combination as I've shown in the presentation. So then we use a common cleaning pig to push the piper forward. So as long as there's flow, then we move forward.
Okay. Great. This one's from for Quantum Pro target. What is your primary short-term goal and the long-term goal going forward?
Okay, no, that's an excellent question. So short-term goal in terms of the tracer monitoring and analysis is basically to get a better insight on each of the well flow profile. Most of the well has no information in terms of the data on the stage level, and a lot of assumptions, and the technology was focused on pre-frac analysis without direct correlation to the output from the design and the deployment of the technology on the post-frac production, the stage level. So that's our goal in terms of expanding the application of the technology, expanding the accuracy in terms of the detection and the footprint across the different basins. But the long term, you see there's a lot of opportunities from flow profile mapping, and it's not only in the conventional multi-stage hydraulic fracturing, but you also see at the larger scale on the offshore and onshore, there is a large operation around water injection and handful recovery, waste disposal, etc., where the technology can be applied very successfully to measure the flow profile vertically and horizontally from the injection well to the production well, and get a better granularity in terms of the injection process, and help operators to optimize the field development and maintain the high level of the production from all the offset wells. So that's kind of a goal in terms of long-term technology application for different areas.
Thank you, Daria. That's good to know for our audience. I'll go ahead and ask the same question to Avatar with FieldPit. What do you think is your, can you please tell us your primary short-term goal and the long-term goal?
Okay. From the inception of the company, most of our opportunities came to us because the interest in the market for augmented reality for field service is huge. So our short-term plan is just to have some more real success stories and use cases in this specific market that we are in, especially in the energy sector. We have today a few, and we hope to have much more in the next couple of months. Just to, I didn't mention it before, we are located in the Silicon Valley, Houston, Denver, and Boston. We have also office in Heidelberg, Germany, and our R&D headquarters is in Tel Aviv. For long term, our objectives are to have our technology embedded within the enterprise software of our customer, within the field service management software and the CRM and other software that the technicians are using today. This is the challenge that most customers are looking for such a solution, and we are already working on it with some of our customers.
Mm-hmm. Thank you. I'll take up another question from the audience. How does the inspection device make it through the walls?
Yes, that's a good question. It's not a problem at all, actually, because again, we are centered in the liquid, so we just push through. Especially for the 2-inch and 3-inch diameter lines, we always ask operators whether the valves are full bore, so there are no issues there. And we have our normal piper is a 2.2-inch in diameter, so that we use in 3-inch lines in diameter and larger. And for the 2-inch lines, we have a 1.5-inch mini piper.
Okay. Thank you. This one's for Mark. Has the accuracy of the well simulations been confirmed against the actual production results? How close are the simulations to the real world?
Yeah, it's an interesting question, and of course it's a complex question for anybody who does subsurface engineering of any kind. So it's very easy to history, well, not very easy, but it is certainly possible to history match a numerical model to real data. That doesn't prove that the numerical model is correct or even useful at all. We're not in a big data environment. We actually have quite limited data. We have, if you're trying to history match production in one well, you've only got production curve versus time, and so on. So certainly in every project we match the data, but I would not warrant that alone proves it's right or reliable. There's many models that could match the data, and many of them are going to be completely useless. So that's kind of step one. You should match the data. Step two is, are we getting predictions of where we don't already know the answer that help companies make decisions? And in the short term, some of my favorites have been like companies have done things like given us a well design from 2 years ago and said, how would you improve this? And we've come back and given them recommendations, and they say, oh yeah, we figured that out in the past 2 years. So that's been something that's built confidence for some of our clients is that we've been able to basically kind of rediscover things that they've had to discover themselves, only it took them years and a lot of money, and we did it very quickly and very cheaply. Another example is an operator. We had a DFIT study looking at interpretation of DFIT tests. We have a paper coming out next month. And their DFIT interpretation was like 100x off what they really felt it was. And when we simulated the DFIT, I didn't modify a single thing in the model. It just came out looking like their data, and we were able to explain, based on the simulation result, why the DFIT interpretation was way off. And that's leading to them and many other operators getting more accurate permeability estimates, which is helping them make better decisions. And we have a paper at ERTEC and a paper at ATCE about that particular study. So that's, the long answer is the proof is when companies make decisions based on our recommendations, and they get back better results. And of course, that takes time. So we have a few of those starting to come back. but there are quite a few companies that have actually guided their changes in design over the past year using ResFrac, seen improved production, or in also cases where they've basically done kind of blind tests over the past few years. So I think it's important for us to keep putting out more white papers. We have a lot of white papers kind of like about to post on our website, which we're redoing, to put more and more of those kind of case studies together, because I recognize that's a critical question for someone to ask. But yeah, hope that answers the question. But yes, we've had a lot of good experience with it, and not just matching data, but actually coming up with recommendations that help companies make money, which is really the point.
Great. Thank you. Thank you for that, Mark. One last question here. The scanning mechanism is azimuth, I assume. That's the question I have. Azimuth 2.
No, that's not the case. We measure in 3 axes, and as you can imagine, if you're free floating, going through a pipeline, anything that if we pass a valve, anything, if there's a slight difference in pressure, we notice that. So it's a pretty complex measurement and analysis that we do, especially because we are free floating. So that is not azimuth.
Okay, great. I got another one from Mark. I guess this is the last one, and we'll wrap it up. So Mark, what are the inputs does your model need? Are those the same with conventional reservoir and fracture models?
Yeah, exactly. Yeah, so it's both. You would need everything like saturation, permeability, rel-perm curves, fluid model. That's what you'd put in a reservoir simulator, and then in a frac simulator you put in things like Young's modulus, Poisson's ratio, fracture toughness. Of course, those are not homogeneous properties; they're spatially variable. And we support different amounts of putting in spatial variability of those properties. So all of those properties that you would use in a frac simulator and a reservoir simulator doesn't have any kind of, unusual new requirements. And then, of course, to history match and compare with data, then you would want to have production data, you'd want to have injection data. And we also like to have microseismic to help constrain fracture geometry. We find that to be very helpful. And any other sort of offset information, offset frac hits, DAS, and a variety of other diagnostic tools that are out there. Tracers, certainly. We've actually found tracers very useful in projects as well.
Thank you so much. And this concludes our briefing for today. I want to thank our panelists for joining us today and sharing the unique and innovative solutions with us. If you have any other questions, please send them to us. Thank you for joining today. Thank you.